Hi, hello everyone. My name is Massimo. I'm a developer advocate at Subsquid, and I want to talk to you about improving the indexing performance with a multi-call contract. This is something, honestly, I'm not sure many people are aware of. I certainly was not when I started creating indexing projects. And I'm going to discuss a little bit the details as to why I didn't initially found out and why it's actually quite important. And some of the like gotchas that you can encounter while doing this. I want to start first of all by introducing Subsquid to those who don't know it. We have been working with Substrate and Polkadot or within the ecosystem for over a year now. We are born and we started in the Polkadot ecosystem, but now, as you can see from the logos in here, we have branched out and expanded to other chains. We're like legitimately multi-chain tool, not just because of the parachains. And in general, let me also introduce the concept of indexing middleware, which is what we call ourselves. The purpose of the indexing middleware is to ingest the on-chain data, and make it available through to dApp developers and dApps through a data processing framework. It's essentially like the name says, something in the middle between the blockchain and the modern dApps that we envision can be built with Subsquid, with us, and are already built. We have some logos here, for example, Talisman. I think many of you are, or even Subwallet, are using Subsquid. Now, as to the peculiarities and what distinguish Subsquid from other similar tools is the fact that we recognized since the very start that data ingestion pipeline, the ingestion process is a pipeline, and it's usually segmented into multiple stages. And some of these stages are actually very different from one use case to another, especially the processing and presenting part. But the ingestion is always the same. It always looks the same because essentially you have to just go through the entirety of the blockchain, process each block one by one, and extract the information. So for this reason, previously built solutions are a monolith, and we recognize default in that design, in that architecture, because at the end of the day, for multiple uses, you still go through the same ingestion, and so there's not just the potential, but actual replication and wasted effort and resources. So for this reason, we have built our architecture to be modular. And we have created a shared extraction service called Archives. Many of you who might already use Subsquid have certainly heard of Archives, and the fact that when you index, you don't connect to the blockchain right away. You actually go through an archive, except for what I'm actually going to show you today. And this is why it's important, because Archives introduce great performance improvements, but sometimes you still have to go through a direct connection to the RPC node because you want to access the state of the contract. And in order to do that, there's no historical information saved in previous blocks. You have to actually access the blockchain node. As for the data flow and how the data is processed, I already spoke about it. Essentially, what an archive does is extracting and ingesting the information and store it on a database, or actually a data storage, because newer generation of archives that we have built use a different kind of storage, Parquet files, not a database. And they finally make this data available through a gateway, in this case, a GraphQL server. And down the line, this is where your customization and ETL, so extract, transform, load process comes. And this is where you develop your squid with our framework. And as to what this design, what these services bring, I already spoke about it, but essentially they are one less thing to care about, because the ingestion part is usually where lots of people start to build their own process, their own projects, their own in-house services, and it takes a lot of maintenance to do. It takes a lot of effort and etc. So we took care of that. You can benefit from it. The other thing is that if you don't want to do that, usually people start by directly connecting to the blockchain, and it's just not simply not designed for that. Um, we have access, we have created these services with a better storage in mind, and consequently a better performance. Finally, you have even improved, even much better performance, because archives allow you to filter and query certain types of information and just completely ignore the rest. So you don't have to go block by block. You just simply can request, hey, give me everything that happened with this address. And it's already pre-filtered out for you. And you can also request it in batches, which is a major improvement over the network communication overhead. The last thing I want to mention is the fact that since it's modular, every single module can be improved. And like I said, we already have a second generation of archives that have a um, different storage architecture. And so by using that, we have already seen performance improvements. Now, as to what squids are, I mentioned that this is where the customization comes in. Squids are what we call projects built with our SDK. Essentially, you take the SDK, you use the libraries to create your own Node.js project that connects to the archive, receives the data, and then by developing your own code, you can apply your custom business logic, save your data in your own database, and serve it to your API if you want to. This is like a usual use case you can find. And what I'm actually going to build in the practical part is, for example, an API for your NFT marketplace. What the benefits are of this SDK are the automated model generation. So you define your schema, and we just take care of creating code for you. You bring your own API, or you just connect to Etherscan or similar services for the smart contract API, and we generate code that interfaces with it. The one benefit as a developer that I find is that this is code and not just configuration. Sometimes services that try to make things too easy for you and just provide you with a sort of like boxed in configuration files. In the end, you don't know exactly what's happening. You are, like I said, boxed in by these config files. And instead, with this SDK, we allow you to be free and just develop whatever you want to. There's much more power in coding your solution. I mentioned the fact that this is code, and the language we decided to go with is TypeScript, because it provides strong typings, and the type safety allows you to reduce bugs. The final thing is to help you out as much as we can. We have a hosting service where you can host your API, and just in a couple of lines of code, command line, you can just deploy your solution really quickly and have a public-facing API. Now, as to what this automated code generation looks like, you basically, like I said, define your schema. You define your entity named owner. It has these fields, and we generate the TypeScript model for you, which is a class, and it has these fields, and they are defined as columns, etc. And in the same way, we define database migrations that will create tables for you. And for the API, you basically just copy paste the API JSON. In this case, we're looking at a function named approve with its inputs, and we will generate the function for you. And you are able to have the inputs of the function as and they're strongly typed. So you make sure that whatever you extract when it's decoded, it's already a string. You don't have to do any weird things to it. I think this is the right function. As to the aquarium hosting service, like I said, you just have to install the library, and you can just execute sqd deploy on the current folder where you're working, and you have your service deployed. One last thing I want to mention is the documentations. They are constantly updated. It's a never-ending effort for us because we're developing quite fast and it's hard to actually catch up. If you want to take a look and browse for yourself what's going on with the SDK, you can just visit the organization GitHub. And I personally curated multiple videos where, like educational videos, I try to go into as much detail as possible and provide tutorials and examples. And if you need help or just curious to chat with other developers using Subsquid, you can look at Discord and or Telegram. And the same videos and tutorials I have published on YouTube are also available as articles on Medium. Now, one thing I wanted to show you actually is, I think it's best if I show you the final example, and then we revert it and start from scratch. Let me open folder. So I have prepared a mini project for today. Maybe it's better if I zoom in. Usually people complain about the screen being too small. This is indexing, actually, this is indexing the Exiled Racers racecraft contract. I don't know if any of you know, but it's a blockchain game, quite famous one. I chose it because the main reason why I chose it is because they have the validated contract available on Moonscan, so you can essentially take a look at their Solidity code. And finally, it has down here, so many files. It has the contract ABI. Some of the contracts available on Moonscan or just deployed on Moonbeam, unfortunately don't have this, so they make your life a little bit harder. But I think you can rest assured that if you browse the ERC-721 tokens and browse any one of these, even if they don't have the, let's pick this one, for example. If you browse contract, you can see that it's not validated, it's not verified. But if you can use just a standard ERC-721 ABI, you should be able to work with it. Like I said, I used this one because at least I could show you the page. So we're going to use this in a second. And the final thing that I want to show you is the fact that there is a contract called Multicall contract. It's the implementation of MakerDAO. There it is. It's the implementation of this Multicall contract from MakerDAO, and there is one or two deployed on Moonbeam. And what this does, it's allowing you to aggregate multiple calls to functions to smart contracts. And I'm going to use this to obtain the token metadata. If I were to just simply poke the Exiled Racers contract, I would have to do one by one, like one call for every NFT. And this is like degrading the performance like vastly. So what I'm doing is instead I'm using the Multicall to do this, and it's saving a lot of time to me. So I think let's start, like I said, let's start with the project. Like I said, I have the ABI here, I have the ERC-721 and the Multicall ABI interface. But let's actually start it. Let's QD up. I'm now starting a database container on Docker, and then I'm just let's building. let's see. Yeah, I have a log that says calling multicall for 1,400 tokens, and you can see it has completed it very quickly. And every time this is sort of aggregating multiple function calls to the original token URL function call of the original contract into one single batch. I'm reading, is it possible to index smart contracts, states, variables? Uh, I think so. Yes. Maybe I'm going to try and answer all the question at the end. Uh, yeah, that's an interesting question. Just I want to show you what exactly I'm doing and how, and then we can maybe code it. I think I have time. So what I'm doing, I have configured a class which is substrate batch processor. This is simply processing substrate blockchain information in batches. I think it's a very self-explanatory name. And I've configured it to connect to Moonbeam archive and to the this RPC endpoint specifically. I need the RPC endpoint because, like I said, I need to connect to the blockchain directly. And then I specified that I'm interested in all the logs from this smart contract, which is the defining here as a constant, and it's the exiled racers. And lastly, I specifically filtered out the events of this smart contract, saying I'm not interested in everything that happened with it. I'm only interested in the transfers. So like reducing the scope a little bit, but for the purpose of the workshop. And plus, I mean, for NFTs, it's most of the things that you're interested in, I guess. And then I'm launching the processor. And like I said, I'm working with batches. So every time I'm essentially creating a query for to the archive, and I'm receiving a batch of these events. And so I need to process them in a vectorial way. So I get a bunch of blocks, and in each blocks there's probably a bunch of items. And so this is why I have this nested for loop. And then I simply check. This is basically a verification, and in this case, because I'm only processing logs. It's sort of redundant, but it's helping me with the strong typings of a TypeScript. If I remove it, I think it's going to complain because of the types that I'm handling. It's not sure that I actually have the EVM log event. Yeah, like you see, it's saying because the item you're processing, I have not verified that it's an EVM log. I'm not sure I have the event field in it. Instead, if I do this, yeah, it's happy. And what I'm doing is I'm using this function that I built down below to process and decode the event itself. This is where the API TypeScript interface comes in, because it comes from here. Actually, I can show you. No, this one. This is automatically generated from the original smart contract API, and I have all the events that are defined in the contract, and I'm specifically using this one. And the code function, but use this function to decode the EVM log, like I'm doing here. So I'm importing the events from the API interface, and I'm choosing the right event, and then I'm decoding the log. And this is the information I'm getting from it, the address that transferred the NFT, the address that received it, and the token ID itself. And I'm saving this information. I'm using this transfer data type, oops, simply out of convenience, but I need it because I'm essentially accumulating all of the information in this batch in an array of this data interface, and then I'm saving everything at the end. I could save on the database each transfer, but this is essentially defeating the purpose. I'm processing everything in batch, saving it in a temporary data storage, and then I'm flushing everything onto the database, everything at the end, and this is saving a lot of time. It's increasing the performance. Now, as to the multi-call and where this comes in, it's right here at the end. This is the save transfer function, and it's doing a bunch of stuff. It's essentially like preparing the data with the right structure, and this is a set that I'm building, a map that I'm building to find out the tokens that I have not yet saved on the database. So actually, it's the opposite. It's finding the tokens that I have on the database, so that when I cannot find anything in this map, it means that I have to create a new one. Now, at the very end, I'm going to skip some of these things. I am instantiating the Multicall contract interface. This is sort of like an API interface that allows me to poke the Multicall contract, and I'm calling the aggregate function, and I'm aggregating all of the token URI functions of the exiled race contract into one single batch, into one single aggregated call, and then I'm processing the results, and I'm putting the each resulting token URL into the corresponding token database interface, database model. And this way, I think if I start another terminal, now I have started a GraphQL playground here on my local machine, and it's collecting the data that I'm saving. They're communicating with the same database. So the processing part saves on the database, and the serve part, the GraphQL part, pulls from it. So if I go here and say localhost, let's, for example, get the token information. I'm limiting to 10 so that I don't have all the thousands of tokens available. And this is where I get the URL. And this should be the metadata of this token. If I go and look it up, it has all the token information, including the images. This is where I said it's an interesting thing to do for example, an NFT marketplace, because what I could do, like the next step I could do in here in the code down below, when I save the token URL, I can also use Axios, for example, to connect to this URL, download the metadata, look up the token image, and for example, take token image URL, and for example, save the token image URL, so that when I'm building my front end, I don't have to do this double jump of fetching the token from the database, fetching the metadata, and then go and also fetch the image. I could just have the token image, and I could just show it. It saves a lot of performance. Now, as to how you can build this, right? This is essentially the fully finished project. I can stop it and tear down the database, tear down this as well, and let's start from fresh. I just do sqd init. And this is a new, also, I think if some of you have used Subsquid in the past, we have changed the command line tooling to make it much easier. I could just create a new project. I don't have to go to GitHub and clone a template. I can, or fork a template. I can just start it from here. So I can just say Angel Hack, yeah. And then I can choose a template where I want to start. I want an EVM. I want to generate squid indexing for any smart contract API, or I want a substrate or a frontier AVM, which is the case of what we're going to do now. And there we go. If we cd into Angel Hack, first of all, I'm going to install the libraries, and then I'm going to open it in here. So just with a couple of comments, I have a project that is ready for me to customize. In this case, it's connecting to Moonriver. I think it's indexing Moonsama. Let's take a look. Yes, it's indexing the Moonsama contract on Moonriver, but I can, with a few changes, I can just say Moonbeam. Then I'm going to change also the endpoint in here. I have it saved somewhere. I could basically copy it from the other project. Give me a sec. Oh yeah, it's just this. Or let me use the other one. There we go. And let's change the contract as well. Or even better, I can copy it from here. I think the multi-call address is the same. Let me double check. There we go. Yes. Now, sorry. So, yeah, the next thing I want to do is import the API and show you how we can generate the code for it. Let me create a JSON file called exrr. Well, it's not JSON. Yep. Okay. And in the terminal, I can just do sqd typegen and provide the name of the file, which is x. Oh, it's in the wrong folder. Oh, it doesn't matter. Oh, I forgot one thing. This is not available yet to all other project. It's actually the changes to SQD command line tool is so new that the template is not ready yet. So I need to import the commands available in here. I just forgot to do it. So now it should be happy. It's doing the typegen command, and this has created the EXRR TypeScript interface for me. And this is what I showed you earlier. It's a collection of all of the events in the smart contract, as well as all of the functions and the contract interface. This is where I can essentially poke and prod the smart contract on chain if I have an RPC endpoint available, and for example, ask for the name and symbol and total supply metadata so that I could avoid hard coding it like this. And actually, I think it's best if we start with that. It's quite a cool thing to show you. And it's also a good way to show you that this works if done once, because there's only one contract, right? And I don't have to ask for this information every time. I could just do it at the beginning of the indexing when I don't have the contract instance available. And instead, when I'm doing it for every token, it's better if I use the multi-call. So the first thing I want to do is in here, instead of creating a new contract model. Oh, I haven't talked about it. Like, what is contract? What is token? It's basically derived by this schema GraphQL file. I have defined 4 entities, namely the token. So for every token that I encounter, I'm going to save its ID, the current owner, the URL, and every time it has been transferred. And then the contract it belongs to. That's why I'm talking about the contract so much. And the contract it belongs to is actually another entity on its own. It has its own ID, which is the address, the name, symbol, total supply, and all the tokens that sort of belong to it. I've spoken about the transfer. So every time I find an occurrence of the transfer event, I'm going to create a new item of this type. So this is going to be a row on the transfer table. It basically translates to a table on the database. And finally, the owner. Simply enough, I think the balance field is not needed, but I'm saving its ID, so the address and all the tokens that it owns. From this from this schema, these models have been generated. It's the same thing that I showed in the slide, just on a bigger scale. For every entity, I have a model file, and I have the contract in here with the class and the columns. But actually, there's a bit of an issue with the naming, because I have the contract entity, but in here in the ABI, I also have, the contract class. These are two separate things. They're two different things, and I'm actually, because I have to import both, I have to rename them. So for example, I can do import contract from the ABI XRR, and I have to rename it. Next, I want to import. I want to change the this to be exported, because I need it on that side. It's going to become clearer in a second. I essentially need this type because I have to instantiate the contract entity, and here I need to import. There we go. We should be good. Maybe the I know for sure that I need the big numbers from Ether's library. Okay, now I can finally do what I was supposed to do. So I need to calculate the, I need to instantiate the contract API, like I said. So let's actually call it cons API. And this is going to be a new contract API. And this is where I think it's best if I show you the constructor of it, of the contract base that it inherits from. So it needs the context. That's why I imported it from the processor. It needs the address and the block where the contract API is getting instantiated. Essentially, because we are indexing the blockchain on a historical basis, it's almost like we're taking a time machine and going back to the past. When I create an instance of this contract API, it needs to know the block where I am at this very point in time, like where I'm indexing. It needs to be, it needs to know that block, and so this is what we need to do. Because I'm receiving the context, and this context is this one, so it's the batch of items that I received. I can use this to know which block I'm at. And because it's a batch, what I'm doing is I'm calculating the latest block of the batch. So what I'm doing is I'm doing context blocks. And then I need everything that is inside the context. Damn it. And then I need to specify the block, and the block is, like I said, the latest of the batch. So I need to say context.blocks. Oh, damn it. I hate when auto-completion gets in the way. context.blocks.length -1 because array programming, and then I need the header from it because the actual block information is saved in the header, and then I need the contract address. Of course, I haven't provided it. Context. Okay. Now with this contract API, I can instantiate temporary variables for the name. Symbol and the symbol equal and the total supply, which is a big number coming from the blockchain, from the smart contract function. It's I know for a fact that it's a big number, and I have to instantiate it with something. It's not liking this. Oh, from 0. Okay. Now we're good to go, and we can say try catch, because the one nice thing about having the context is that I can use it to log, and I have a better, it's better than console log because I don't know, it's prettier, and it tells me exactly where the log happened in terms of who executed the don't have it available. Well, I'll show you in a second. I can say just warning the I don't know, contract address. That's it. And what I'm doing here is I can do name equals await contract API dot name. Yeah, it's not liking because I need to make this asynchronous. I can do the same thing for symbol. And total supply. Now I need to assign the value that I just gathered. And I need to convert it to a big integer because the contract model defines this as a big integer. The big number is a specific type from ethers. Now, obviously, this is not happy because I'm not passing it the context, and I need to also change it to here, ctx context. Yes, this is context.store, and this is also context.store. And I need to return a promise because it's asynchronous now. And I need to await. Yeah. Okay, so what is happening now when this function is getting called is going to check if I have this singleton instance of a contract. If not, it's going to try and get it, and it's going to try and get it from the database. If it's still not available, it's going to create a new one. And the way it's going to create it's by actually contacting the on-chain contract via the API and accessing the actual real values from it. Like I said, this is standard contract communication that is available thanks to the SDK, but it's not very performant. If I were to do the same thing, let's say down, something like this. If I were to do the same thing like here, which is doing, by the way, the standard contract is doing the same thing that I just did by instantiating the contract Where is it? I think it's at the top. No. Oh yeah, there it is. Sorry, it's instantiating the contract, smart contract interface essentially, and it's requesting the token information, but it's very slow. I think I can actually maybe swap this one for the smart contract that we decided to index right now. And I think I can show you that it's not perfect. SQD build, SQD up, and SQD process. This is the abstract. Like you see, it's basically bombarding the node with connections, asking for the token metadata for each one, token URL for each one of them, and it has not even finished the batch, right? So we're going to see a message in a little while. It has to go through all of the initial 1,400 tokens that it has found, and this is not ideal. So what we're going to do instead is we're going to use the multi-call contract that is actually already in here. Let me still have it available so that we can see when the batch has finished processing. But in the meantime, we can change the code to what I want to show you guys. Maybe for better results, or in order for us to be quicker, I can just show you the changes that needs. Yeah, there it is. So it has just finished the first batch, right? It has been quite slow. So SQD down, and instead of implementing the whole thing, I can just show you what needs to be done. So instead of doing this, when I'm creating a new token, this is a new one, I don't have the information available, so I can just say, okay, put a placeholder in here. Don't communicate with the chain, because right here at the end, this is a loop that is looping over all of the transfer information that we have found in here in the batch. Sorry, up here, right? I'm collecting all of this information in this array, and then I'm calling the save transfer function with the entire batch, with the entire process information. So what it's doing is doing some preliminary operations, like I said, building maps of instances that we already have on the database to save performance, essentially, to avoid rewriting them and updating them or trying to create them without any need. And it's just looping over them, trying to save all the owners that we have encountered with the transfers, all of the tokens that we have found, and it's creating a new transfer entry in the table every time. So right here at the end, maybe I can show you just by copy pasting. It's probably quicker than me coding it live. And then I can explain the code. I need to import the multi-call contract first, of course. Oh yeah, I haven't created it. So actually, this is a good time to show you how, because obviously I showed you how to create this from the smart contract API, and how we can actually create an interface for the multi-call contract. You can just do SQD typegen -- multi-call. Actually, let's do -- help so I can show you how it works. So what this command behind the scenes does, it's calling this other comments, the command that comes with the SDK, and it's accepting two arguments. The first one is implicit; it's the output directory, and if I don't put anything, it's just going to put it in source ABI. And the second one is the ABI file, like I said, the JSON. Now, if I want to create a multi-call interface, I just need to type -- multi-call, and I don't even need the ABI. It's just gonna take for granted that since it's a multi-call, it complies with the, sorry, where is it? I closed it, I think, with the multi-call, with the MakerDAO. There it is. With the MakerDAO multi-call API. It's just going to take for granted, and it's going to create a default interface for it. Let's just do it. So SQD type gen -- multi-call. And here we have this one. I'll leave you guys to just go through it. But I want to highlight the fact that this is different from the other one, from the EXRR. As you can see, this one has like its own stuff. It's like an ERC-721 on steroids. They have added their own custom functions to it, but in essence, it's got the name owner, symbol, like we said, and other stuff. But the multi-call one, it's the main thing that we're going to use is the aggregate function, because this is what's allowing me to aggregate multiple calls to the same contract. So now I can import it. There we go. I'm going to import this as well. And yeah, I need to import this one. Yeah. So once again, I needed to calculate the maximum height of the current batch that I'm exploring, because in order to instantiate the multi-call contract interface, I need to provide the context and the block number. Then I obviously need to provide you with the contract address. Now, what I'm doing here is I'm using this to call the aggregate function, and the function that I want to aggregate is the token URL of the original Exile Race contract. I provide its address, and then what I'm doing is I'm creating this map, which is essentially for every item that I found in my data processing, I only need the token ID, because the token URL function, what's needing, it's the ID. So what I'm doing here, what I'm doing here is in the aggregate function, I need to provide the function I want to call, the address, and then the argument of such function. In this case, the token ID. The last argument is pagination, because obviously since it's an aggregated call, maybe it's like I said, 1400 token IDs. It needs to be paginated, and it's paginated by 100. Next, for each result, I'm simply trying to find the token instance, like this guy right here, from the token map that I built, given its ID. Simple enough. I have built this mapping that is mapping the token ID to the token model, that interfaces with the database, and I'm fetching the token model with the given ID, and I'm using the fact that all of these array are ordered in the same order. Now that I have the token model, I'm just simply replacing the placeholder empty URL with the result that I've been given by the multi-call. It looks maybe more complex than it actually is, and let's actually build it and run it. The expectation is that we should see exactly what I showed in the beginning. So SQD build. I haven't changed anything else, so yeah, we should be good to go. SQD up. SQD process. So here we should see, yeah, I have the login here, which is kind of annoying, but you have seen that like it's basically gone through all of the initial. Actually, you know what? It's better if I just remove this, so you can see that he's basically going through all of this in one go. It actually was too quick. SQD build with the new code. an SQL process. So instead of, yeah, I need to like tear down the database and restart. Otherwise, we're too ahead. We don't start from the same spot. Yep, doesn't work if you don't specify SQL. In just a finger. So this is how you can leverage the SDK, and not just the SDK, the Multicall. We didn't invent it. It's actually a great idea from MakerDAO. But this is how you can improve your indexing performance by thousandfold, I guess. The one issue that you have to be aware of is that being able to, and it's actually something I discovered recently. I wasn't fully aware of this, but it kind of makes sense if you think about it. Like I said, every time you're indexing, it's almost like you're taking a time machine and going back in time to the time when the blocks was created. And so if the multi-call contract was deployed after the token transfer or the, I don't know, the event that you're exploring, it's not going to be able to provide that information for you. So you always have to make sure that the multi-call contract was deployed before the event you're trying to access, or the smart contract, yeah, the smart contract event you're trying to access. It's kind of like a gotcha, like I said, but it's quite an important one. And I think, yeah, this is it. This is the end of the workshop. If you have any questions, I'm going to try and take a better look at the chat, or you can maybe, I don't know if you guys can take the stage and talk. Trying to read PP's question. Is it possible to dynamically append a smart contract SC that my screen is indexing? So you're basically talking about making sure that you can create multiple of these, right? I think the best course of action is either, so first of all, we support factory contracts, and that is a different matter, but it kind of solves partially the issue for you. Instead, if you're just, I don't know, if you have multiple collections, different ones, instance of it that has the new contract, have it re-index entirely. Unfortunately, you have to start from scratch. And then what you can do to the new one when it's ready. I don't know if it was clear for you, but it's kind of like a trick where, yeah, you have to create a second instance with the new contract and the old one and just swap it. By the way, like, we have made all of this because unfortunately, sometimes this is the way to go. And if indexing is this fast, your problem is going to be solved in a matter of, like, I don't know, depending on the size of the contract, maybe it's like a couple of hours. Other similar solutions might take, I don't know, a couple of weeks. Next, does Subsquid work with any substrate-based chain? Yes. Yeah, we actually do have an interlay archive. I think I can try and show you here. This should be auto-suggesting me. So yeah, as you can see, we have a list: Akala, Aleph 0, Astar, Bajul, and there we go. We have interlay. So there we go. And then I think, is it possible dynamically? Yep. Okay. Same people are saying how to create all of them. So what you can do, actually, that's yeah, what Frank Beaver is requesting is, instead of specifying the address, if they're all the same kind, you can just have, for example, a star here, and then you can provide the ERC20. Let's say actually it's ERC721 for the purpose of this, because I already have the ABI for it. I can just do I can just do this import from the ERC721, and then essentially I can map all of the events from all of the addresses that comply to this topic. So every time a certain topic, like let's say the transfer of any ERC721 is encountered on chain, by using the wildcard, it's not going to be filtering by address. It's going to take care of all of them. One thing, the initial request was: is it possible to index smart contract state variables holding a list of proposals? Yes, that's sort of what I did with the name, etc. The counterpart to that for purely substrate chains. So actually, the substrate counterpart to EVM smart contract is available. It's just slightly different. Let me try and bring up the docs maybe really quickly. Developer Squid, substrate processor, state queries. There it is. So this is how you can access the types, the storage. And this is what I was trying to, I forgot the name. So you can access the storage simply by creating the equivalent of the ABI interface for substrate. It's just going to create a bunch of classes, and you can specify that you want the storage, and then it has your interface like this. And by the way, it's very important that I say this, that all of this stuff is resilient to runtime upgrade. So for example, the storage at a certain block has certain typings, then there was a runtime upgrade and it got changed. We have SV, this function is gonna double check the hash of the type and make sure that it complies with it, with the runtime version that it was written on chain, so that you're safe from potential mistakes. You don't have to do sort of spaghetti code to double check. Yep. Can you talk through how it would query years? Yeah, PSP 22 is Inc. So we have Inc. Smart contract. I think from our standpoint is it's working. It's demonstrated. It's working essentially the same way you just saw from EVN. You have an Inc. typegen. You just specify the ABI, the Inc. ABI, and it will just create interfaces for you, very similar. Then you can decode the messages, like everything is there. Yeah, the difference is probably that you have less support. I haven't seen any Explorer that give you all of this information. It's much less supported. Can you talk through how it would improve a real-world use case? For instance, we're building a real estate NFT marketplace. I think I mentioned it while I was while I was building this whole thing. In essence, having your data stored like this, make sure that when I index it, it's already available for me on the database, and from like the API exposes this, so that let's actually launch it again and I can show you. Make serve, no, actually serve. This mini project, this small Node.js, is executing on my local machine, but what I can do with it is I have access to this, and this is just a playground. But essentially, if you have your NFT, what you said, it's yeah, a real estate NFT marketplace. I'm sure you're building a front end for it. In your React code, I guess, you can just use your deployed API and essentially make queries to it, and the queries are going to look like this. I don't know how familiar you are with GraphQL, but this is essentially the same thing as a REST API. It's just instead of incorporating the query in your URL, you just explicit in the form of a JSON text, and you get your data. The difference is this data is already sort of prefetched, pre-processed. It's available here instead of accessing directly the blockchain. I showed you just by doing what's it called? Just by doing this little query here to fetch the token URL from the chain has slowed down my processing by a lot. Imagine if you have to do this in a web page. It's simply not going to deliver the right user experience that you want to. Instead, you can just do this in a nice way like I showed you, have it stored on your database, have your API, and your front end will connect to the API, not to the blockchain. I have a slide in here. Like one of the first slides that I had is this. So if you're building a modern dApp, instead of connecting to the blockchain, you can use this middleware like here, and you will connect to the API. So you can just simply create your query and you just say get NFTs, get me the NFTs where the owner is Alice. There we go. You've done it. You found it. The answer. Otherwise, you would have to have particular smart contracts. ERC-729, for example, would not do the job for you because they don't have, they don't have the necessary information. They don't have the current owner of a certain token, I think. But even if they do, yeah, no, it's fine. Yeah, I think I ran out of time already by 1 minute. If you have any more questions, I have left some of this slides in here with the resources, especially Discord and Telegram, and you can reach out and ask for any other questions you might have. Yeah, feel free to search for me on LinkedIn as well, on LinkedIn, sorry, on Twitter. Yeah, this is my Twitter. My name is, where am I? Yeah, is Raekwon with 3 I's. So those are not L's or number ones, they are 3 I's. Yeah, thank you. Thanks everyone.